Hello guys, welcome to Ncert Science. We are reading class 6 Science chapter number 7 Motion and Measurement of Distance. There was a general discussion among the children in Paheli and Bujo's class about the place they had visited during the summer vacation. Someone had gone to their native village by a train, then a bus and finally a bullock cart. One student had travelled by an aeroplane. Another spent many days of his holidays going on fishing trips in his uncle's boat. The teacher then asked them to read newspaper article that mentioned about a small wheeled vehicle that moved on the soil of Mars and conducted experiment. These vehicles were taken by spacecraft all the way to Mars. Meanwhile, Paheli had been reading a story about ancient India and wanted to know how people traveled from one place to another in earlier times. Story of transport. Long ago, people did not have any means of transport. They used to move only on foot and carry goods on their back. Later on, they began to use animals for transportation. For transport through water routes, boats were used for ancient time. To begin with, boats were simple logs of wood in which a hollow cavity could be made. Later, people learned to put together different pieces of wood and give space to the boat. These shapes created the shape of animal living in water. Recall our discussion for this streamlined shape of fish in chapter 5 and 6. Invention of wheel made a great change in mode of transport. The design of the wheels was improved over thousands of years. Animals were used to pull carts that move on wheels. Until the beginning of the 19th century, people still depended on animal boats and ships to transport them from place to place. The invention of a steam engine led to the development of new means of transport. Railroads were made for steam engine driven carriages and wagons. There came automobiles such as motor cars, trucks, and buses. Motorized boats and ships were used as means of transport on water. The early year of 1900 show the development of aeroplanes. These were later improved to carry passengers and goods. Electric trains, monorails, supersonic aeroplanes, and spacecraft are some of the contributions of the 20th century. Figure 7.1 shows some of the different modes of transport. Place them in the correct order. From the earliest mode of transport to the most recent, are there any of the modes of transport that are not in use today? How wide is this desk? How did people know how far they have traveled? How will you know whether you can walk all the way to your schools or whether you will need to take a bus or a rickshaw to reach your school? When you need to purchase something, it is possible for you to walk the market. How will you know the answer of these questions? It is often important to know how far a place is so that we can have an idea how we are going to reach that place. Walk, take a bus or a train, a ship, an aeroplane, or even a spacecraft. Sometimes there are objects whose length and width we need to know. In Paheli and Bujo's classroom, there are large desks which are to be shared by two students. Paheli and Bujo share one desk but frequently end up objecting that the other is using a large share of desk. On the teacher's suggestion, they decide to measure the length of the desk, make a mark exactly in the middle of it, and draw a line to separate the two halves of the desk. Both Paheli and Bujo are very fond of playing gilli danda with their friends. Bujo brought a set of gilli and danda with him. Here is how they try to measure the length of desk using the danda and the gilli. The desk seem to be having a length equal to 2 danda length and 2 lengths of the gilli. Drawing a line in the middle of the desk leaves each of them happy with half of the desk equal to danda and gilli in the length. After a few days, the marked line gets wiped out. Bujo now has a new sets of gilli and danda, and he lost his old one. Here is how the length of desk seems to measure using the gilli and danda. Hello. Now, when measured with the new sets of gilli and danda, the desk length seems to be about 2 dandas length. 1 gilli length will a small length still left out. This is less than 1 gilli length. Now what would you suggest Paheli and Bujo do? Do measure the length of the whole desk? Can they use a cricket wicket and bells to measure the length, or do you think that he might create a similar problem? One thing they could do is to a small length of string and mark 2 point on it. This will be a string length. They can measure the width of the desk in string lengths. How can they use the string to measure distance less than the length of a string? They can fold the string and mark it into 1 by 2 and 1 by 4 and 1 by 8 string lengths. Now perhaps Paheli and Bujo can measure the exact length of the desk using the string. You would say that they should use the scales in their geometry box and solve their problem. Yes, of course. Bujo has been reading about the way people used to measure distance before such standard scales were made, and he has been trying to follow different method of measuring distance. There are so many occasions when we come across a need to measure length and distance. The tailor needs to measure the length of the clothes to know if it is enough to stitch a kurta. A carpenter needs to measure the height and width of the cupboard to know how much wood he would need to make its door. The farmer needs to know the length and the width of the area of his land to know how much seeds he can sow and how much water would be needed for his crops. Suppose you are asked how tall you are, and you want to tell the length of a straight line from top of your head to the heel of your feet. How long is this room? How wide is this desk? How far is it from Delhi to Lucknow? How far away in the moon from the earth? All these questions have one thing in common. They all concern distance between two places. The two places may be close enough, like the two ends of a table, or they may be far apart, like Jammu and Kanyakumari. Let us do a few measurements to see what exactly we need to do when we measure distance or length. Some measurement. Activity 1. Work in group, and each of you do this activity one by one. Using your foot as a unit of length, measure the length and width of the classroom. It is possible that while measuring this, you may find some parts remain to be measured as it is smaller than your foot. Use a string to measure the length of a part of your foot as you did before. Record your observation in table 7.1. Measuring length and width of classroom. Activity 2. Work in a group, and each of you use your hand span and as a unit of measure to the width of the table and the desk in classroom. Here too you may find that you need a string length equal to your hand span and then fraction of this string length to make the measurement. Record all observation in table 7.2. We see that measurement means the comparison of an unknown quantities with some known quantities. This known fixed quantity is called unit. The result of the measurement is expressed in two parts. One part is a number, the other part is a unit of measurement. For example, if in activity 1 the length of the room is found to be 12 length of your foot, then 12 is the number and the foot length is the unit selected for the measurement. Now study all the measurement recorded in table 7.1 and 7.2 are all the measurement for the room using everybody force equal. Are everybody measurement by hand span of the width of the table equal? Perhaps the result could be different as the length of your hand span and that of your friends may not be the same. Similarly, the length of the foot may be slightly different for all the students. Therefore, when you tell your measurement using your hand span or length of foot as a unit of other, they will not be able to understand how big the actual length is unless they know the length of your hand span or foot. See therefore that some standard unit of measurement are needed that do not change from person to person. Standard unit of measurement. In ancient time, the length of a foot and the width of a finger and the distance of a step were commonly used as different unit of a measurement. The people of Indus Valley civilization must have used very good measurement of length because we see evidence in excavations of perfectly geometrical constructions. A cubit as the length from elbow to the fingertip was used in ancient Egypt and was also accepted as a unit of length in other parts of the world. People also use the foot as the unit of length in different parts of the world. The length of a foot used varied slightly from region to region. People measured a yard of cloth by the distance between the end of the outstretched arm and their chin. Romans measured with their pace or step. In ancient India, small length measurement used were an angle, finger, or a muthi fist. Even today, we can see flower sailor using their forearm as a unit of length for garland in many towns of India. Many such body parts continue to be in use as unit of length when convenient. However, every one body part could be the slightly different sizes. This must have caused confusion in measurement. In 1790, the French created a standard unit of measurement called the metric system. For the sake of uniformity, scientists all over the world have accepted a set of standard unit of measurement. The system of unit now used is known as the International System of Unit (SI units). The SI unit of a length is a meter. A meter scale is shown figure 7.6. Also shows in the 15 centimeter scale in your geometry box. Each meter is divided into 100 equal divisions called centimeters. Each centimeter has 10 equal divisions called millimeters. Thus, 1 meter equal to 100 centimeter and 1 centimeter equal to 10 millimeter. For measuring large distance, meter is not a convenient unit. We define the larger unit of length. It is called kilometer. 1 kilometer is 1000 meter. Now we can repeat all our measurement activities using a standard scale and measure in SI units. Before we do that, we do need to know the correct way of measuring length and distance. Correct measurement of length. In our daily life, we use various types of measuring device. We use a meter scale for measuring length. A tailor uses a tape, whereas a cloth merchant uses a meter rod. For measuring the length of an object, you must choose a suitable device. You cannot measure the gait of a tree or a size of your chest using a meter scale, for instance. Measuring tape is more suitable for this. For a small measurement such as the length of your pencil, you can use a 15 centimeter scale for your geometry box. In taking measurement of length, we need to take care of the following. Place the scale in contact with the object along its length as shown in the figure 7.7. In some scales, the end may be broken. You may not be able to see the zero mark clearly. In such cases, you should avoid taking measurement from the zero mark of the scale. You can use any other full mark of the scale, say 1.0 centimeter. Then you must subtract the reading of these marks from the reading at the other end. For example, in figure 7.8b, the reading at one end is 1.0 centimeter and at the other end it is 14.3 centimeter. Therefore, the length of the object is 14.3 1.0 centimeter and equal to 13.3 centimeter. Correct position of the eye is also important for taking measurement. Your eye must be exactly in the front of the point where the measurement is to be taken as shown in figure 7.9. Position B is the correct position of the eye. Note that from position B, the reading is 7.5 cm. From position A and C, the readings may be different. Activity 3. Measure the height of your classmate using handspan and then by using a meter scales. For this, ask your classmate to stand with his back against a wall. Make a mark on the wall exactly above his head. Now, measure the distance from the floor to the mark on the wall with your handspan and then with a meter scale. Let all other students measure this length is a similar way. Record all observation in table 7.3. Study carefully result obtained by different students. The result in column 2 may be different from each other as the length of handspan may be different for the different student. Look at the result in column 3 where the measurements are done using a standard scale. The result may be close to each other now, but are they exactly equal? If not, why do you think there is a difference? After all, everybody is using the same scale and do not different hand spans. This could be due to the small errors in taking observation. In higher classes, we will learn about the importance of knowing and handling such errors in measurement. Measure the length of the curved line. We cannot measure the length of a curved line directly by using a meter scale. We can use a thread to measure the length of curved line. Activity 4. Use a thread to measure the length of curved line. AB. Put a knot on the thread near on its end. Place their knot on the point A. Now place a small portion of the thread along line. Keeping it taut using your finger and thumb. Hold the thread and end point with one hand. Using the other hand, stretch a little more portion of the thread along the curved line. On repeating this process till the other end B of the curved line is reached, make a mark on the thread where it touches the end B. Now stretch the thread along the meter scale. Measure the length between the knot is the beginning and the final mark on the thread. This gives the length of curved line AB. We see that we need a lot of care to ensure that we are measuring distance and length correctly, and we need some standard unit and device with which we measure this distance and can convey our result to others. Moving things around us. Activity 5. Think of some object you have seen recently. List them in table 7.4. These may include a school bags, a mosquitoes, a tables, people sitting on chair or people moving about. The list may also have a butterfly, a dog, a cow, your hands, a small baby, a fish in water, a house, a factory, a piece of stone, a horse, a ball, a bat, a moving train and swing machine, a wall clock or the hand of a clock. Make your list as large as you can. Which of these are moving, which are at the rest? How did you decide whether an object in a motion or at rest? You might have noticed that the bird is not the same place after some time, while the table is at the same place on this basis. You may have decided whether an object is at rest or in motion. Let us look at the motion of an ant closely. Activity 6. Selected a place where you find ants. Spread a large sheets of white paper on the ground and keep the little sugar on it. Ants are likely to be attracted to the sugar, and you will find many ants crawling on the sheet of the paper soon. For any one ant, try to make a small mark with the pencil near its position when it has just crawled onto the sheet of paper. Keep marking its position after a few seconds as it moves along on the sheet of paper. After some time, shake the paper free of the sugar and the ants can connect the different points you have marked where arrows to show the direction in which the ant was Moving each point you have marked shown where the amount moved to in interval of a few seconds. Motion seems to be some kinds of a change in the position of an object with time, isn't it? In activity 5, where did you place object like a clock, a sewing machine or an electric fan in your grouping of object? Are these objects moving from one place to other? No. Do you notice movement in any of their parts? The blades of their fan, the hand of the clock? How are they moving? Is their movement similar to that of an ant or the train? Let us now look of some types of motion to help to understand these different types of motion. You may have observed the motion of vehicle or the straight road, march past or the soldiers in a parade or the falling of a stone. What kind of motion is this? A sprinter in a 100-meter race also have along the straight track. Can you think of the more such example from your surrounding? In all these examples, we see that the object moving along the straight line, this types of motion is called rectilinear motion. Activity 7. Take a stone, tie a thread to it while it with your hand. Observe the motion of the stone. We see that the stone moves along the circular path. In this motion, the distance of the stone from your hand remains the same. These types of motion is called circular motion. The motion of a point mark on the blade of an electric fan, of the hand of clock are example of circular motion. The entire fan or the clock by themselves are not moving from one place to another, but the blade of the fan rotated are so do the hand of clock. If we mark a point anywhere on the blade of a fan or the hand of a clock, the distance of this point from the center of the fan or the clock will remain the same as if they rotate. In some cases, an object repeats its motion after some time. This type of motion is called periodic motion. Take the stone tied with a string that you use in activity 7. Now hold the strings in your hand and let the stone hang from it. This is the pendulum. Pull the stones to one side with the other hand and let it go. Now the pendulum is in motion. It is an example of periodic motion. A branch or a tree moving and fro. Motion of a child on a string or of a guitar or the member of drum tabla being played, where an object or a part of the repeated its motion after a fixed interval of time. Did you observe a sewing machine as a part of activity 5? You must have observed that it remains at the same location while any point of its wheels move with a circular motion. It is also has a needle that moves up to down continuously as long as the wheels rotates, isn't it? This needle is undergoing the periodic motion. You have observed closely the motion of a ball along the ground. Here, the ball is rolling on the ground, rotating as well as moving forward along the ground. Thus, the ball undergoes a rectilinear motion as well as the rotational motion. Can you think of other example where objects undergo combination of different types of motion? We did many measurement activity and discussed some kinds of motion. We show that motion is a change in the position of an object with time. The change in the position can be determined through distance measurement. This allows us to know how fast or slow a motion is. The movement of a snail on a ground, a butterfly flitting from flower to flower, a river flowing, an aeroplane flying, a moon going around the earth, and blood flowing inside our body show that there is a motion everywhere around us. Keywords: circular motion, distance measurement, motion, periodic motion, rectilinear motion. SI units of the measurement.